This is question 8, part B of the Seoul National University's Mathematics Aptitude test that was held in 13th of February 2018. The reason I chose this question is because it is a typical KSAT style manipulation question related to the topic of calculus and really requires real understanding of the definition of some calculus processes and not the techniques and methods itself. So let's get straight to it. The question is simple. Find the limit as n approaches infinity of n times the integral from 1 over n to 3 over n of e to the 2x plus 1 times cosine of x cubed dx. Many of you might have noticed that we cannot integrate this, well, with the familiar methods that we already have of integration by parts or the reverse product rule, because in order to use the reverse product rule, it has to be in a style of the integration of u dv equals uv minus integral of v du. However, if you choose either one to be u or dv, you can see that even if you integrate, or differentiate, either one you will get a more complex answer. So that is not the question here. So what I'll do first, because this is a manipulation question and the limits bounds of 1 over n does not really look good and easy, I will substitute this. I will let t equals 1 over n. Then as n approaches infinity, t approaches 0, right? So we can rewrite the whole equation as the limit as t approaches 0 of 1 over t times the integral of from t to 3t of e to the 2x plus 1 times cosine of x cubed dx. Now let's call the function inside as fx. So let the capital of fx be the integral, the indefinite integral of e to the 2x plus 1 times cosine of x cubed dx, and let capital Fx prime be small f of x, which is equal to e to the 2x plus 1 times cosine of x cubed. Because this is an indefinite integral, if you differentiate it, you'll just end up with the original function inside. So the question here is, the real question, if we say that, the limit of, as t approaches 0, of 1 over t times the indefinite integral of capital F of 3t minus capital F of t, right? So now if you look at it, if you rewrite this in a more formal or easier way, minus f of t. Now this looks very familiar. This looks like a definition of a limit, which is looks like the formal definition of limit, a limit as h approaches to 0 of f of x plus h minus f of h divided by h, right? This looks like that. So we can actually manipulate this big limit into two parts. Because we have 3t, t, and t, we would like to separate the 3t with the 3 t's on one side and the t's on the other. So we can actually write this as the limit as t approaches 0 of f of 3t minus f of 0 divided by t minus capital F of t minus f of 0, all divided by t. Because if you simplify the negatives, it will be f of 0 divided by t plus f of 0 divided by t. So the f of zeros will cancel out, leading to our original function. Our original limit. So doing this does not change a thing at all. Now I can distribute the limits with our limit rules. So the limit as t approaches 0 of f of capital 3t minus capital F of 0 divided by t minus the limit as t approaches 0 of capital F of t minus f of 0 over t. Now notice that this part is equal to capital F prime of 0, right? Because this is a formal definition of a limit. So this is where x equals 0. Because, this is f prime of x, right? So when x is 0, this is what we get. Therefore, our real question is, how can we manipulate the left-hand side? Well, that's also easy. Because we have 3t over here, we can just let everything to be 3t. So our goal is to change this to 3 and change this to 3. But how do we do that? Well, the limit as t approaches 0, we can write 3, and we can multiply 3, and then we can divide 3, right? Because that will not change the limit. And it doesn't matter for the limit of what t approaches. If t approaches 0, then 3t will also approach 0. As t approaches 0, 3t will also approach 0. It's just a constant multiplied, so we can change the limits as well. Minus the limit as t approaches 0 of f t minus f 0 divided by t, right? This limit now we can write as 3 times f of 0, f prime of 0, minus f prime of 0, right? Because those are the definition of our limits. So we can write this as 2 times capital F prime of 0, therefore 2 times small f of 0, and from our definition, f of x is that, so from here, f of 0 equals e to the 1 times cosine to the 0, right? Which is just e, because cosine of 0 is 1. Therefore, we can rewrite this as 2 times e. This is a simple manipulation question that is a Korean style. Thank you very much.